So hello everyone, sorry for the technical glitch. As the first part of what I have explained till now in this class, the video is not recorded properly, the visual is not there, and that's why the everything also like got shut up. So let's restart. So I have started from this. This is happened when we discuss linear polarization. The polarization is epsilon not chi e. But for non-linear polarization, we have this quadratic term and the cubic term. So because of the nonlinear property of the matter, or you can say nonlinear, because of nonlinear optics, we can say some optical phenomena, namely second harmonic generation, third harmonic generation, subsequently high harmonic generation. So because of this quadratic term, we get basically second harmonic generation for this like cubic term, we get third harmonic generation and so on and so forth. And later on we will get to know that for symmetric system we will not get even harmonics, we will get only odd harmonics. So to know how these nonlinear effects take in place, we need to know that we need to take into account that the refractive index, up to now we did know that refractive index has only real part. It would be wrong to say that refractive index has only real part. We believe that refractive index is a real number, but from now on we will get to know that refractive index has an imaginary part as well. So I hope you have gone through the lecture series and you already knew that the refractive index has an imaginary part, and that imaginary part is connected to the absorption coefficient. So we start our discussion from the light matter interaction. So basically the interaction means both party will get affected by the other party. So the matter will be affected by the light, which is the electromagnetic wave, and the light will also be affected by the matter. So first we see that what light does to matter. So when an atoms encounter an electric field or light, see, this week's assignment is basically some like there is no mathematical problem. They are basically all like theoretical problem. So let me just go through the theoretical concepts covered in the class. So when an atom encounters an electric field, the electric cloud of the atom start oscillating with the frequency of the electric field. Most probably with the frequency of the electric field. This line is not corrected, that the atoms start oscillating only with the frequency of the electric field. So we know that the equation of the motion the electron cloud becomes me d2xe dt square plus 2me dxe dt plus me omega naught square xe. Is equal to e e naught e to the power minus I omega minus I omega t. So basically, if you remember, we have seen this type of equation in acoustics as well as LCR circuit. So this gamma is basically damping coefficient. This is MA. This is because of damping. And this is the restoring force. And all this would be sustained by the force from the light wave. So after solving this equation, and now okay, XE T is basically displacement center from cloud. So the solution we get from this equation is basically E by ME omega naught square minus omega square minus 2I omega gamma. And with that, we'll get the electric field. Or you can write this E0 naught 3 exponential minus I t. So the omega is the frequency of incident electric field. So the factor E by ME give a minus sign. So that's how they are out of phase by pi. And this is e to the power I pi. So this is basically minus 1 by omega naught square minus omega square minus 2 by omega tau E t. It's pi out of phase with the incident electric field. So here are two cases. So omega naught is the natural frequency of electron. So there are two cases. When omega is less than omega naught, x e t became minus 1 by omega square e t, which would be almost equal to et. So here the electron cloud will oscillate at the frequency of omega, but the amplitude will be decreased. When omega is almost equal to omega naught, x e t will be minus I1 by gamma e t, which can be written as minus I e t. So this is the resonance. The resonance. Okay, so we can write this e t to the power I pi. This can be written as e t e to the power minus I pi by 2, not minus. And when omega is greater than omega naught, then x e t became minus 1 by omega square e t, which is e t. So in every case, we have seen that the electron cloud of the atom start oscillating with the frequency of the electric field, but the amplitude can vary. And when the frequency of the electric field and natural frequency of the electron is equal, then we will get the resonance condition. So that's why I say that almost every time that the electron cloud starts oscillating with the frequency of the electric field. And why I said almost? Because when the electron cloud has a natural frequency equal to the frequency of the electric field, it starts resonating. So basically, it doesn't change its frequency to electric field because its frequency already was almost equal to the electric field. But their amplitude get modified uh, according to this calculation we have seen. So when the omega is very less than the natural frequency of the electron cloud, we get 180-degree out of phase situation. When they are equal, we get 90-degree out of phase situation. And when the frequency of the electric field is way up greater than the natural frequency of the electron cloud, we get that they are in phase. So now we go on to dive into the thing we have learned, that is a Lorentzian model or Lorentz oscillator model. This thing, what we have derived, E by N E omega naught square minus omega square minus 2 pi omega tau et. This can be written as so this part can be written as 1 by minus 1 omega naught square minus omega square minus 2 omega et. So that is can be written as E by N E by 2 omega 1 minus omega naught by omega minus eta. Here there is step of calculation what the professor has already discussed in the class. So basically when omega, we are assuming, not when, we are assuming this omega almost equal to omega naught, that means omega naught plus omega is equal to 2 omega. And now we will consider omega naught and omega is delta. So this thing can be written as E by N into omega 1 minus delta I delta. Delta I is tau, that can be written as delta square plus tau square I delta square plus tau square. This part is the real part. And this part is imaginary part. So delta is a constant. Tau. And this delta is omega naught minus omega. So, and we know the graph as well, that if we we normalize these two things and we draw a graph. So this graph corresponds to imaginary part, which we see that it's a very even part, and I have done a mistake. It should be more sharp. Delta curve is odd. Okay, that is a real delta by a delta square as tau square. So when omega naught is equal to omega, that means delta became 0. So real part became, but the imaginary part became delta by delta square, which is 1 by delta. So this is imaginary and became maximum. Because tau is already a constant. But when delta becomes 0, its denominator uh, becomes small. So when denominator becomes small, the whole fraction became large. So that's why the imaginary part became 0 here. So this is what a electric field does to a matter. So when electric field when electric field incident on the molecule or atom, they polarize the first. They need to polarize the like electron cloud and nucleus has to be polarized, and you will get to know that. And then the electron cloud start oscillating, and because of the oscillation, the electron cloud start oscillating with the frequency of the electric field, and if the frequency is already equal to the electric field, then we'll get the resonance. Now we need to that light does to matter. Now we need to know what matter does to light. So before I start there, first we need to know. We need to have a conclusion that what Lorentz oscillator model does. So it describes behavior of an electron in an atom in amplitude and phase of an electron motion depends on the relative phase on the frequencies. So you have seen that when omega is less than omega naught, that the electric field frequency or the driving field frequency is less than the natural frequency of electron, we get that the oscillation is 180 degree out of phase of the incident field. When they are equal, they are like 90 degree out of phase, and when the electric field of the driving frequency of the driving electric field is much greater than the natural frequency of the electron, they are in wave phase. So that's the important thing. We also know that and also the amplitude got decreased. Sometimes it remains the same, but it doesn't remain the same. The amplitude got changes. And electron and the incident field oscillates at the same frequency. And when delta becomes zero or the resonance condition, the even function, or we can say imaginary part, is maximum. So now we should go into what does the matter does to light. So basically, if this is a medium, the electric field incident on the medium, and that is transmitted electric field after L. This is the at each layer incident electric field inside the atoms in the light emitted from the excited atoms or light emitted from the oscillated electron cloud interacts with incident light beam. Incident light beam, and we get transmitted wave, which is basically incident light plus emitted light. So that is what matter does to light. And this light, or this is basically electric field. So this electric field has polarized polarization component because there is polarization happening. As we know that when the electric field fall on the molecule, this electric field polarize the electric cloud. And that electric cloud starts oscillating. So the electric field that the transmitted has polarized component. So we know the Maxwell's equations. So that is divergence of D is rho by epsilon, divergence of B equal to 0, curl of E is equal to minus del B del T, and curl of H is basically del D del T plus J. So basically D is a displacement vector is equal to this, and H basically, so we can write. So for so n goes to 0, should become divergence of E is equal to 0, divergence of B is equal to B, curl of B is equal to mu naught epsilon naught del B del T plus mu naught del B del T. The polarization is there. So the polarization is a vector. So it has a Ex, Py, Ez. And electric field has a Ex, Ey, and Ez. Unfortunately, it's not a linear relation that Px will lead to Ex and Py will lead to Ey and Pz will lead to Ez. No, that's not the case. So what happened px, py, pz can be written as like a tensor equation. So there is chi, which is susceptibility, that is for linear polarization is 3 by 3 matrices. So basically for most of the cases when there is like a symmetric thing happening, the chi 1 2 and chi 2 1 will be the same, chi 1 3 and chi 3 1 will be the same, chi 2 3 and chi 3 2 will be the same, and there like moment of inertia will get a coordinate system where the chi tensor only have the diagonal elements. That system is called principal axis system. Now we like goes to like the electric field. So now if we like do the calculation, so we take curl of E, that would give us curl of minus del B del T. So we'll get a equation, electromagnetic equation in 1D will be del square E del Z square minus 1 by C square del square E del T square is equal to mu 0 del square P del T square. So previously we have seen equation without here in the equation we have seen del Z square minus 1 by C square del square P by del T square is equal to 0. That was a like homogeneous equation. So now there is a p polarization. The polarization is basically dipole moment per unit volume. So we can write this as a dp by dv, that is small p. So small p is basically what we have seen, that q into e, that is the dipole moment. So p somehow related to e. We say that p is epsilon naught. So that's how p is related to e. I don't understand how this came into like how does that come in how why we thought that polarization is connected to electric field is like is this. So epsilon naught chi E. So for 1D, this is like this. And we are using the summation notation. So basically, that means they are summing over the repeated quantity. So like this. The polarization also can be written as N E into XET. So XE is displacement, but it is also behaving like oscillating electric field. Because remember, so this N is the number of particles in a volume, and E is the charge of electron, and it is its displacement. If now we put the values here of XE, we get to see this. This is omega naught minus omega minus I delta E field. So that is chi into E. So now we can write mu 0 del square P del T square is equal to shell and not V naught chi del square E del T square, which is chi C naught square del square E del T square. So the equation became del square E del Z square minus 1 plus chi C square del square E del T square is equal to 0. And if we like compare with electromagnetic wave equation in matter, like 1 by v square v square e del T square equal to 0. So 1 plus chi C naught square is equal to 1 by v square. So C is equal to C by N. So N is basically 1 plus chi, which is susceptibility. So now, if we put this, so we know that the solution for this solution for equation 1 is E naught exponential I k z minus omega t. So that is became because kz is omega by c z minus omega t. C is actually V. V is basically C naught. We should say C naught by 1 plus chi. If we put this value is here C, we'll get that this equation So the professor has shown this thing in the lecture, that how the calculation take place. And always remember, this is all the linear. We are discussing. In a bit, we will discuss. Becomes a naught exponential minus alpha by 2 into z exponential I k naught mz minus 1. So that electric field is oscillating with the frequency omega. What do we have said earlier? So alpha is basically imaginary part of chi, and the real part of, like I have already mentioned, that m is equal to m plus I kappa. Okay, so kappa is associated with alpha, and real part of reflective index is half real part of chi plus 1. So total is real part of chi plus I imaginary part of chi. So if you remember, this is epsilon chi, and this part we can write as delta by delta square by tau square plus I imaginary tau by delta square plus tau square. So this is the real part of, real part of chi is something like this with some constant, and imaginary part of chi is with some constant in the square plus tau square. And you can see we have also see mathematically when delta is 0, imaginary part goes to maximum, or from this graph also when delta is 0 we get the imaginary part maximum, which is 1. And this is not the one actually, that is the normalization constant. So but at that point it gets maximum. So the imaginary part of the susceptibility also represents the absorption behavior, and that function is peaked at the resonance frequency. So the imaginary chi is at maximum when delta is equal to 0, which was omega almost equal to omega naught, and represents absorption behavior. So from this, we get to know light or electromagnetic incident on a sorry, it should be the same. Then it start falling because here it is lambda naught and here it is lambda naught again. So the absorption depth one by alpha. So when we are in linear domain, frequency doesn't change, lambda changes. We get new frequencies only when we go into non-linear domain. And also minimum frequency and reflective index, we get some this kind of phenomenon. So this part, refractive index increases, so omega is increasing. But at this part, when omega is increasing, refractive index is decreasing. So that is called anomalous dispersion. Anomalous dispersion, and this is called normal dispersion. So, and one thing here that the susceptibility depends on the real part of the susceptibility, not depends on the real part of the susceptibility. The susceptibility is constitute of the real part of susceptibility and imaginary part of susceptibility. And when you see part and real part, what do you see? That is, it involves delta. Delta is basically omega naught minus omega. So It depends on the frequency. So you need to remember all those things, that the chi, the imaginary of the part of the chi, is basically an event function, and it gets maximum when delta is equal to 0, and delta depends on the omega frequencies, so they are all connected. Now, gives this what the wave and how wave and matter interact, and we assume that that interaction is linear. But now we need to go where the interaction is not linear at all. We can that means matter's response is not linear. So what does that mean? So maybe in your bachelor's level optics, you have a radio polarization. There is some materials on crystal where they have like uh, E axis and another O axis, that is a extraordinary axis and the ordinary axis, and the refractive index at E axis and refractive index and O axis is not equal. So basically, the matter's response is not linear in all directions. So for that part, what I have done that Pi is not only XLJ, EJ, but there is different part. Is epsilon XIJ E J E K and so on. Epsilon not I J K L E J E K E L and so on and so forth. So for that we like so if in a Coulomb potential if you assume that is a harmonic region, an electron oscillates in that region, that is harmonic approximation, and that denotes linear region. But when that potential energy depart from the harmonic approximation, it's basically is a nonlinear region. So this is harmonic. So if you add a quadratic term or minus a quadratic term, it becomes like this or like this. So when electron moves in this kind of potential or this kind of potential, then it behaves non-linearly. So basically double harmonic generation means we get double the frequency. So in medium, we incident omega and we get 2 omega. So in 11th week classes, we get to know that it's not always that we get 2. So if we get omega 1 and omega 2, we get 2 omega 1, 2 omega 2, omega 1 plus omega 2, omega 1 minus omega 2, and between everything. So if we use omega, then we get 2 omega, omega, omega and omega. So we get 2 omega and 0 also. So basically, we get anything from 0 to 2 omega. So basically, we get 0 and 2 omega because they are the combination. You take both the electromagnetic waves at omega. So what happened that omega 2 is basically 2 omega 1 and n omega 2 refractive index of n omega 2 would be refractive index of n2 omega naught. That would be the case. And so when this thing happened, during SHG or other harmonic oscillation, main thing you need to remember conservation of energy and momentum always. Momentum followed by the photons. Always. So if we get frequency which is double the previous frequency, So lambda becomes lambda by 2. So if we incident red light, we can have green light. And in the nonlinear region, frequency does change. That's why also the lambda changes. But the nonlinear tangent is nonlinear generation, that conventional nonlinear harmonics and SSG, TH, G and so on. And there is high harmonic generation. You get to know that the SSG and THG has a limitation that when you produce second harmonics and third harmonics, the intensity drops. That's how it works. But if we need high harmonics like seventh order, ninth order, and 11th order, you get to know that we need that those things at high frequency as well, or with high intensity as well. So for that, we need high harmonic generation, and this procedure are different because we only want three-step procedure, and all those procedures for with which we generate high harmonics. And what is the specialty of this high harmonics? That that third harmonic, seventh harmonic, ninth harmonic, fifth harmonic, they have the same intensity. So that is the specialty of high harmonic generation. So now, like I want to some very important and basic thing, that is units. Start from the start. So we know meters, which can be written as meter, which is defined as L. Then mass, that's the length. Its length, mass, and time. So length is basically like this. Mass is denoted by one dimensional axis. It's like this. That it in a cell is a meter, kg. So if meters is million and this is second. Okay. And the force, which will be MA, this is the dimension, and that is kg meter square, kg meter per second square, and that is called Newton. And unit of energy is Joule, which is kg meter square per second square, which is written as mLT to the power minus 2. So energy and work is on the same. And the electrical unit of charge is coulomb. So we know Coulomb's law, force is basically Q1, Q2, 4, 5, epsilon, and so matter. So here we know that epsilon naught is 8.85 into the 1 minus 12 farad per meter, which is farad is also coulomb per point. And this force also follows the same dimension of Newton. And field is electric field into Q. So the electric field unit is basically volt per meter. So we know the Maxwell's equation as curl of E equal to minus del B del T, curl of H is equal to my del T del T plus J. Divergence of E equal to 0 or rho by epsilon naught, basically. And you can say it divergence of D or by epsilon naught. Divergence of B is equal to 0. So the electric field as basically unit of m t to the power minus 2 c1 or q1 if you say the charge is like this. This force has the same. So basically, this is the Maxwell equation. Force is basically electric field into charge, and I'm going to write the units of this units. That is volt per meter. Displacement vector is coulomb per meter square. This is Tesla or magnetic field or induction. Magnetic intensity is ampere per meter. Acha, current is denoted as ampere, which is coulomb, 1 coulomb into time. Or that is called magnetic intensity. H, that is magnetic field or induction, was the same. Polarization also has, sorry, it should be coulomb per meter square, same as P, otherwise they will not add up. We have P plus P. So P and D has to be the same unit. Like it was wrong to say that they will not add up. Basically, with polarization, when you multiply epsilon P, then it add up and give you the displacement vector. And the magnetization in is ampere per meter. As we have seen, H is equal to P by mu. So here you can see, you can minus D and P, we get something. So if they are not have same unit, you will not get the subtraction. Here you cannot add up. Tesla is Weber computer square. So Weber is unit of magnetic flux. And Weber is equivalent to 1 joule per ampere. Okay. And as I have already mentioned, that polarization represents electric dipole moment per unit volume, and magnetization is magnetization. It pole moment per unit volume. So there is another one, free charge density, or you can say charge density. So the charge density is in units of coulombs per meter cube. And J is another thing, that is free current density, which is amperes per meter square. And J is also connected to sigma E electric field. That is, from microscopic Ohm's law, we get this law. You will not see this equation in this course, but that is also there. So sigma is called electrical conductivity. So the sigma's units are ohm inverse, meter inverse. These are the unit. And ohm is basically volt per ampere. So see, electric field is volt per meter and J is amperes per meter square. So sigma ohm per meter. So meter cancel out. So basically sigma is ampere by volt per meter. So ampere by volt is 1 by ohm into meter. If you remember this equation and some basic units, you can get to that some other unit. That's the like catch of this unit and dimension. And one thing I missed, that is sigma. So mu naught is called permeability. Epsilon naught is permittivity. This is permeability. This is equal to 1.26 into 10 to the power minus 6 H per meter. H is called Henry. So unhenry is 1 Weber per ampere, or we can say 1 volt second per ampere. These things are pretty obvious, but still people like forget those things. And then we got a master formula that force on a particle of a charge q moving at velocity v through an electromagnetic field is given by Lorentz force. So that is q plus v. So the dimension of f and q will be equal, and dimension of f and QVB will be equal. So D is basically epsilon E plus P. That P is epsilon chi E. So basically it is 1 plus chi E. That 1 plus chi is written as epsilon. Okay, similarly we can write as M as chi M H. Oh, always remember these are all linear. And we got mu0 mu M H. So you will say that D is epsilon not epsilon E. Why not me H is equal to epsilon, mu not mu M into B, because the relationship is basically plus M. That's why this H it is. So that becomes 1 plus chi M H. So from that we get this. So epsilon so the one means linear basically. And there is a pointing vector. Is basically E plus H. And there is called energy density. V cross V dot D and V dot H. And when we get expectation value, we get 2n epsilon naught C E naught square K. And when we get expectation values, you get 2 E naught square. Is 1 by C square. Root over mu naught epsilon naught is basically 1 by epsilon naught. This thing is called impedance. free space. And the intensity I is basically 2m divided epsilon naught and mu naught into E naught square. That can be written as 2m epsilon of C E naught whole square. That is our I. Or we say half of epsilon of C is square. So there is some like boundary conditions, but that are not important. Lastly, I want to just mention Gaussian system. In that system, force is basically Q1, Q2 by R square R cap. And the equation got changed. V dot T is 4 pi rho. V dot T, values of T is 0. Kind of P is minus 1 by C del square B del T. No, sorry, that should not be. Name color H invisible 1 by C del B by del T plus 4 pi by C J. So why we will choose Gaussian system where we have SI system already? The remarkable feature of Gaussian system is that is basically E, D, V, H, P, M all have same dimension. That's why sometimes we see that in books it is done in a Gaussian system. So this basically and which is what that is stat volt per centimeter, or you can write as stat coulomb per centimeter square. Gosh, it can be this or state or and write it as a arc by centimeter cube. And in Gaussian system, rho unit is stat coulomb per centimeter cube, and free charge density is stat ampere per centimeter square. J is sigma E. And the relation also changed, that is E plus 4 pi P and H. There is no epsilon and mu in a Gaussian system because you see that D, E, H, B, M, P all has same dimension. So the P is basically chi E, M is H, D is only epsilon E, U is mu M H, and epsilon 1 is 1 plus 4 pi chi 1, and mu 1 is equal to 1 plus 4 pi is mu n is equal to 4 pi chi 1. And here the Lorentz field is given by F is equal to Q E plus V by C cross B, and E is given by 1 by 8 pi E dot D plus B dot H, and S is given by C by 4 pi E cross H. And its unit is given by MC 2 pi E naught square, okay, and U expectation value of U is given by H square by 2 pi E naught H square. Now we go into the nonlinear optics. No, like this. And so on and so forth. So pi 2 has the dimension of 1 by E. Pi 3 has the dimension 1 under E square. So that is in Gaussian is centimeter by stat volt, but in SI Gauss in SI is basically meter by volt. Similarly, it is centimeter square by stat volt square, but it is meter square or volt square in SI. So this unit we know, this unit we know. So it can be written as chi 1 P T chi 2 into E into E, and so on so on. So chi 1 into E should, chi 2 into E should be equivalent to chi 1 in dimension analysis. So what I have written is I almost written the quotient system. In the cell system, we need to add a good shell. So that's for today. We will continue our discussion of non-linearity in the next class. Thank you.